We are glad you are interested in the topic of ApplicationSelect. In this video, we will explain how ApplicationSelect works. With specific proximity sensors, such as variants of the W4S and W12 with background suppression, ApplicationSelect can be added to the basic function of background suppression. ApplicationSelect is a performance booster, which allows an almost doubling of the sensing range, a considerable reduction of the black-white shift, and the hysteresis. That this is no voodoo, but based on ingenious ASIC technology and how it works, we would like to explain now. The ASIC is a microprocessor developed by SICK AG itself, which was developed to meet the requirements of photoelectric sensors. W4S and W12 are already using the ASIC of the 5th generation. The experience of now 5th generation enables us to offer photoelectric sensors and the photoelectric proximity switches with above average performance data. The secret of the ASIC is the digitization of the photocurrents directly at the pixels. This reduces noise and increases sensitivity. This alone brings an increase of performance. However, we achieve the biggest lift when we process the digital data. We can play around with this data and create new features and customer benefits through digital signal processing. By the way, most optical experts are taking advantage of this opportunity. But what exactly happens now with the ApplicationSelect function?
In the sectional view of the W4S, we see the operation of a photoelectric proximity switch with background suppression. With the pinpoint emitting LED and the emitting lens, a sharply defined light beam is generated, which produces a light spot on an object. This light spot is imaged backwards by means of the receiving lens on the multi-pixel receiver array and generates a photocurrent here. As already mentioned, this photocurrent is digitized directly at the pixel. The result is a digital signal current that can be evaluated with special algorithm. In order to work reliably, the sensor must distinguish its own transmitted light from ambient light generated by LED lamps or camera system illuminations, for example. It achieves this by the ASIC sending out a sequence of packets of 4 transmitted pulses each. The ASIC filters these pulse patterns from the receiver's digital signal stream.
In standard mode without ApplicationSelect, each pulse pattern is evaluated individually. In this mode, the sensor typically operates with a switching frequency of 1000 Hz and a response time of 0.5 milliseconds. Here, the intensity of the received signal plays a major role.
Since digital signals are present, we consider the signals in the unit digits. If the sensor looks out into the open, it is clear that no transmitted light is reflected and no useful signal is generated at the receiver. However, the value is not zero since EMC irradiation and the electronic generates noise. A signal that can be evaluated must consequently have a defined distance to the noise. For this purpose, a threshold is set internally in the ASIC. If the signal is above the threshold, an evaluation takes place. If the signal is below the threshold, an evaluation isn't possible. Clearly, if a bright object is detected, a great amount of light is reflected, captured, and a stable signal is available. If a poorly emitting object is now viewed at an angle, such as a car tire, the light is absorbed or reflected away, and only a homeopathic amount of light reaches the receiver. The signal drops so far that it no longer has sufficient distance to the noise and cannot be evaluated.
What happens now in background suppression mode with ApplicationSelect switched on? Why does it suddenly work with the car tire in a slanted position with ApplicationSelect? Why can we also significantly increase the precision and almost double the sensing range? It's quite simple. We have developed an algorithm that specifically evaluates the digital signal stream.
The algorithm integrates up to 32 transmitted light pulse patterns. In this way, a received signal that is below the threshold becomes a signal that is clearly above the threshold. The sensor thus becomes more sensitive and can consequently reliably detect objects at greater distance, at an angle, and objects that reflect little to hardly any light.
Because the sensor needs more time for accumulation and evaluation, the sensors have a longer response time, which is typically around 15 milliseconds. With the additional application select function, a more robust object detection is achieved that is second to none. The sensors with application select are easier to set up, can be integrated reliably into machines, and allow for a smaller installation situation. Additionally, in our newest devices there's also an interstage between standard background suppression and application select, called balance mode, to be even more flexible and application specific. In short, using application select saves you time and money. We hope we have explained the application select function in an understandable way, and thank you for your time.